Assalamualaikum, salam sejahtera and salam Malaysia Madani. I am Syakir Zulhazim Minchasan and I also represent my team members. We are proud to share our project titled Smart Palmeye Detection System for Palm Bunches using YOLO and drone technology. This innovation was developed under FTK UTHM for helping industry and also for i-RITEC 2025 with real industry production. And our tagline is growing yield with AI. So before we go further, let's take a quick look at the working environment in the palm oil industry, specifically in the plantation and harvesting sector. Workers here face a constant challenge that affect in productivity and safety. First, fruit bunch counting is often done manually. This process is tiring, time-consuming and prone to human error, which can reduce accuracy and affect harvest planning. Second one, inconsistent assessment of bunch ripeness can lead to premature harvesting or ripe bunches, causing losses in both yield and quality. And third one, without proper monitoring, plantation supervisors may lack reliable data to make a timely harvesting decision. And finally, inefficiencies in harvest scheduling can lead to waste with overripe bunches left uncollected in the field. And all of these challenges highlight the critical need for automation and accurate monitoring, and that exactly where Smart Palmeye comes in, providing a real-time detection, counting and harvest readiness assessment powered by AI. Fruit bunch monitoring in the palm oil industry is still highly dependent on manual counting. This leads to delays in obtaining accurate data, inconsistencies between workers and missed opportunities for timely harvesting. There is an urgent need for an automated real-time solution to ensure accurate counting and better harvesting planning. To solve these challenges, we developed Smart Palmeye, an AI-driven video analytic system that automatically detects and counts palm fruit bunches in real time. It works seamlessly with drones and camera sources, enabling plantation to continuously monitor tree harvest readiness and generate reliable data for better decision making. Here, how Smart Palmeye works. A drone or camera is deployed in the plantation to capture live video of palm trees. The video is sent to our system where the AI YOLO detector with tracking and IOU filtering automatically detects and counts palm fruit bunches for each tree, and each tree session is tracked using QR codes, and the system records results into both a master log CSV and also per tree summary file. This process data is then linked with the plantation's schematic map, where trees are tagged and those ready for harvest are highlighted. All of this happen in real time with no need for manual counting, and making the process fast, accurate and fully automated. Next, Smart Palmeye has reached technology readiness level 6, which is TRL6, which means it has been tested in a real plantation environment and is ready for pilot deployment. We also benchmark the Smart Palmeye against existing approaches, including the AI-powered FFP, ripeness detection pipeline. While that system is effective for classifying bunch ripeness, underripe, ripe, overripe, and it is mostly designed for research and require extensive data preparation, labeling and control testing. In comparison, Smart Palmeye goes further by providing real-time fruit bunch counting linked to each tree using QR sessions, automated logging into both master CSV and per tree reports, and Streamlit dashboard plus schematic mapping, giving the supervisors immediate harvest insight, and seamless integration with drone or fixed cameras under changing plantation condition. This makes Smart Palmeye not just accurate but also deployment ready, scalable and highly practical for real-world plantation operations. And these innovations directly support labor efficiency, rural empowerment and contribute to the Sustainable Development Goal (SDG), such as life on land, decent work and industry innovation. We also conduct a patent search and found over 60 patents related to this field. Interestingly, most of the patented applications are not focused on AI-driven palm fruit bunch detection. Instead, they are largely in the broader domains of image recognition, crop monitoring, and general machine learning method. And this show that Smart Palmeye offer a novel and under-patented approach, especially in the context of real-time fruit bunch counting and harvest readiness monitoring in palm oil plantation. The market potential for Smart Palmeye is highly promising, both locally and globally. At the national level, our target stakeholders include Kementerian Perdagangan dan Komoditi (KPK) for improving productivity and sustainability in plantation, and next the Kementerian Sumber Manusia (DOSH) for supporting digital transformation in plantation workforce management, and also MOSTI for advancing AI-driven agriculture innovation. At the international level, Smart Palm Oil can be expanded to other palm oil producing countries such as Indonesia, Thailand, Brazil, and Colombia, where efficient harvest monitoring is equally critical. We conducted market due diligence and identified that is solution meets high industry demand, especially in palm oil plantation. The system is also scalable to other agricultural sectors such as rubber, cocoa, and fruit orchard, where automated yield monitoring and harvest readiness are equally important. And next one, we collaborated with Victory and Ho Plantations, Sendirian Berhad, to conduct real-world testing of Smart Palm Eye in an actual plantation environment. Our research findings have been published in Scopus Index and also in APIAT, and demonstrating the academic contribution and innovation value of this system. In terms of protection, we have secure copyright under MyIPO, and most importantly, this project is proudly funded by the GPPS grant from UTHM, which has supported both the development and successful validation of Smart Palm Eye. As we can see here, the letter of intent (LOI) between UTHM and Victory and Ho Plantation as a partner specifically in palm oil industry. On the right side, the certificate of the copyright. Then here was the paper publication sections. On the left was the acceptance letter of the journal article, and on the right was the from my published thesis that related to drone technology. Last but not least, Smart Palm Eye isn't just smart, it's also easy to use. We built a user-friendly web platform using Streamlit, so supervisors can monitor harvest readiness in real time from their laptop or phone, and the system allows you to view live detections, track per tree harvest history, and access archive session instantly, and the results are automatically logged into CSV report and visualized on an interactive plantation schematic map, where trees that are ready for harvest are clearly highlighted, and it is like having a digital plantation assistant working 24/7 to provide accurate real-time insight for better decision making. And let's take a look for the demonstration of the system working. Right now, we see on the dashboard of the Streamlit application, as we can see here, the Smart Palm Eye application, and we can see as the plantation layout schematic grid that we have a feature that can create the schematic layout for the plantation, and all of this is the QR that will produce, and here is the schematic diagram for the plantation layout, and we can reset the CSV log master. We scroll up here, we can set the value of what we want to choose the grid of the layout. As we can see here, we set as 3 times 3, and we got the 9 tree of the palm tree, and we set again 5 times 5. We generate the layout. It provides us the QR and the tree ID. We can save the layout, and we can generate the QR code. Also, we can download the QR code. And here's the 5 times 5 layout of the palm tree. We set the video source, as I use here the video source of a tree, and we start the stream. So here is the setting on the lab. When the QR code appears once, and it detect and make a counting, and it will counting, and we set the ready to harvest as 1, and it detect the tree right. if I set the detect 1 right, it will show the ready to harvest, and as you can see that the harvest layout. And we test to the next tree. As before, we used the tree 14, and here we use tree number 8. Keep detect and counting. And as it show again the QR code, it will stop, and we have to click the stop button, and it show the how much the ready to harvest tree, and also it marked to the schematic layout. Okay, again, next one we will test on the real world plantations, as we test at the palm tree. They keep detect and also counting. After detecting and counting everything, it detect again the QR code, and it will stop the detection and also the counting. And as we can see here, that tree is showing the abnormal, and it will not count as the for the harvest, ready to harvest tree. Alright, that's all from me, I think. Thank you.